Yeah, squirt, 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 squirt. Look at a little blurry there. Shine that up there. Thanks for being here. Getting ready for our final exam. Nice. Okay, so we are finishing helping you get ready for your final exam, quarter one. Let's go. So go back through Canvas. Look at all those even problems and do them again for fun, right? That'll help you get ready for the final exam, unless I blocked them up. Hopefully not. And so go through and look at those. How do we complete the square? Do you remember how to complete the square? So we send the 10 way over here, right? And then we have x squared minus 8x. So basically we have a square and we need to complete it, right? X squared minus 8x plus 10 is not factorable. It factors in 2 and 5 and that doesn't add up to 8. But if we take the b, divide by 2 and square it, that'll make it factorable. Right? So we take the negative 8, we divide by 2, and we square it. So that's the formula, divide by 2 and square it. So negative 8 divided by 2 is a negative 4. And then if we square it, we get a positive 16. Wee-oh! So we're going to go ahead now and add 16 to complete the square. But you can't just add it from nothing. You've got to like take 0 and then nothing and split it into positive and negative. Then they cancel each other out, and that's legal in math. So you can plus 16, but you also have to minus 16 also. Okay? So make sure you do both. So now this factors into x and x, and 16 breaks down into 4 and 4. And the sign in the middle term goes with a bigger number, but they both have to be negative to get a positive 16. So that, and how many x minus 4s do I have now? Pause me, try that on your own. Pause me. So I have 2 of them. And 10 minus 16 is negative 6. 10 minus 16 is negative 6. So we bring that down, and there is our vertex. Whoa, there's our vertex form. So y equals x minus 4 all squared minus 6. And so do we have a vertical stretch? No. But we do have an x-axis. We do have a axis of symmetry. Way-o. And so our axis of symmetry, do you remember that? So our axis of symmetry is just the x value, not negative 4, but positive 4. That's the axis of symmetry. And our vertex, remember what our vertex is? It's going to be not left 4, but right 4. Remember, it's opposite. So right 4 down 6 is going to be our vertex. So don't forget how to do that. Mr. Newbold, what if it's the harder one with the stinking divide by 3 and the fraction? Right? So let's show you how to do that as well. So we have to divide by 3 all the way across, and then send the 7/3 away. So then 3 divided by 3, pull that out here. That's going to hang out there for a while. So we'll have x squared minus, let me see, is it x squared minus 4? Yeah, 3's go away because we pulled it out. So minus 4x. And then we have to complete the square to both sides there. So we're going to go and complete the square. Take the b, divide by 2, and square it. So negative 4 divided by 2 is a negative 2. And then we're going to square that, and we get a what? We get a positive 4. So we're going to add 4 here and minus 4 there. Complete the square. Complete the square. So then that's going to factor. Did you know that easily that's just going to factor into x and x and whatever this is? So negative 2 to negative 2. That's going to work. So then we get x minus 2 all squared. But we still have a parenthesis, and we still have to bring down that 3 is the problem. Remember, because we pulled out that 3 originally? Yep, it's still there. It's still there. Okay, how do we do 7/3 minus 4? Well, any whole number can be written over the number 1. And so if we times it by 3 to the top and bottom, that's 7/3 minus 12/3. Because 4 is 12/3, because 12 divided by 3 is 4. So 7 minus 12 is what? Negative 5/3? Way-o. So we have negative 5/3. Good. However, now we can distribute that 3 there. And we also have to distribute it here, so times it by a 3. And so those are just going to cancel. So our vertex form is 3x minus 2all squared minus 5 with a vertex of 2, negative 5. Wayo. So I can see him asking for the vertex on that kind of problem. We have to complete the square. Oh yeah, this is asking for the vertex. We will not vertex form. Sorry. There's your vertex. Cool. Okay, do we have a vertical stretch? We do. We have a 3. And does that make it narrower or wider? Do you remember? It makes it narrower, narrower. Wider is the fraction. So there's our answer there. We could ask that. Is this narrower or wider, right? That's a good question. Convert the following quadratic function to standard form, then list the requested information. I can see you doing that for sure. So we have to multiply first. What the? So we have to go ahead and multiply first the x minus 4s. So how many x minus 4s do I have? How many do I have? I have 2 of them. So x minus 4 times x minus 4. So you have to do that first before you can multiply the half through or add the 2. PEMDAS, parentheses first. So x times x is x squared. We get a negative 4x and another negative 4x. And the negative times the negative is a positive 16. Pause me, you should be trying this on your own. What are you doing? I'm waiting. Pause me, try it on your own. That's how you're going to do it on the final. You got to be able to do it yourself. Okay, so we have x squared. Pause me. Minus 8x plus 16, good. So then we're going to bring a negative 1/2. And we are going to distribute it through. Whoa, distribute it through. So we get negative 1/2 x squared. Negative times a negative is a positive. And half of 8 is 4x. And then minus 16 and negative half, so that's negative 8. Because 16 times a negative 1/2 is negative 8. Cool. So last but not least, we just need to bring that too. And so we're going to bring that 2 and we're going to add 2 with that guy. So that's going to be a negative 6. So our function then, is y equals negative 1/2 x squared plus 4x and then minus 6. And our y-intercept is negative 6 or 0, negative 6. And are we concave up or down? Well, there's a negative in front. So that means we're concave down. Concave down. There we go. Concave down. Cool. Convert the following quadratic function to factored form, and then this requests the information. So I pull out a GCF, you guys, if it's at a 4 or 4x. Well, the 40 doesn't have an x there, so we can't do that. Just 4, just 4. So then we're left with x squared plus 3x minus 10. Can that factor more? You better try on the final exam. They can factor more. Factored form. So that factors in x and x, and 2 times 5. Sign of the middle term goes with the bigger number. So positive 5, negative 2. But when you set each of those equal to 0, we'll divide that 4 to the other side, so that just goes away. So to get the x-intercepts, you have to set each of those equal to 0. And so when you do that, you add 2 to the other side, so you get x equals 2. And then minus 5 to the other side, we get x equals negative 5. So we have 2, 0, and negative 5, 0 as our x-intercepts. As our x-intercepts. Nice. Is there a vertical stretch? Yeah, there is. There's a 4. There's a 4 in front. So we have a vertical stretch, which makes it narrower, right? Remember, fraction makes it wider, and a bigger number in front makes it narrower. Okay, good job. Okay, so now, given the vertex and a point, could you find the quadratic equation in vertex form? So first you got to write this on your note card. What's our form? So our form is y equals a times x minus h all squared plus k. So this is your h and your k. K. And so 3 goes here, and 2 goes there. Hey, look, they gave us a point on the graph that it passes through. That's your x and your y. So negative 15 goes there, and negative 1 goes there. Plug them all in. So we get negative 15 for our y equals a. We're solving for a. X is negative 1 minus h is 2 all squared plus your k, which is 3. So now we got to carefully simplify. Be careful, because that a is actually multiplied, so you can't combine it with a 3, not yet. So negative 1 and negative 2 is negative 3. And negative 3 squared is a 9. So we have 9 times a, which is 9a. And then we bring our plus 3 down. We bring our negative 15 down. So how do we solve for a now? How do we solve for a? So we're going to minus 3 to the other side, minus 3. So that becomes actually a negative 18. Whoa! And then how do we solve for a? We divide by 9. Divide by 9. So what's negative 18 divided by 9? So a equals negative a half. Way-o! Now that's not our answer. That's part of the answer. Part of the final answer for this problem. And so what you have to do now is plug that back into the equation with y and x and then your h and your k. So our final answer will be y equals negative 1/2 times x minus 2 all squared plus our k value. And that's our final answer. So you're doing the same thing next with the x-intercepts. But this time you have a different formula. We have y is equal to a times x minus r1 times x minus r2. And that's called the factored form. We learned that in Unit 2, factored form. Factored form. So your r1 goes here and your r2 goes here. And that's your x and your y. So our y is going to be negative 9 equals a times your x is in two places. So that's going to be a negative 2 minus r1 is a 4 times x again is negative 2, the point they give us, negative 2, minus r2, which is already a negative. So negative and negative is a positive 8, right? Positive 8 minus 2 is 6. And this is a negative 6 times a equals negative 9. Good. Okay, so negative 6 times 6 is a negative 36 times a. And now we just have to divide that to the other side. And negative divided by negative is a positive. And so that's going to be 9 over 36, which reduces, divided by 9. So we get 1/4 is our a value. So our final answer is y equals 1/4, which is our a value we just found, times x minus the x-intercept times x minus a minus 8, which is a plus 8. And that, my friends, is the factored form. They gave us the two x-intercepts and a point on the graph to help us find our a value, and now we got our factored form. Way-o! Okay, last but not least, use the regression feature on your calculator to determine the quadratic equation for the parabola of the passage of these points. So we have our L1, and our L2. And so that's going to be 0, 2, negative 1, 9, and 3, 5. Because these are our x values, or L1. That's L1. And then these are our y values, which is L2. And so we just go ahead and plug it into our calculator. Go to Stat, edit, go to Stat button. Remember this? Know this for the test. Edit your data. And so now we're going to plug those numbers in. So in place of those, I'm going to go 0 for my x value, -1 for my other x value, and 3 for my, 3 for my other x value. So 0, 1, -3 for my x values, and then 2, 9, and 5. 2, 9, and 5. Do you remember where quadratic is? You got to remember for the final. Put on your note card. So stat edit is what we just did. Now stat over to calc. So stat over to calc, and then we do one of our stats. No, that's for statistics. We do option 5, quadratic. So we push enter. We want L1, second L1, and second L2. And then we're going to go ahead and calculate that. And so there's our equation. There's our equation. Write it down. So y equals, what's our a value? 2x squared. So then we get y is equal to 2x squared. What's our b value next? -5x. So -5. Don't forget your letters. Don't forget x. And then plus c, where your c value is just a 2. So you're going to do the same exact thing with a hiker kicking a pebble off of a cliff that's 18 feet above the river, right? So then we go ahead and draw 18 feet in the air. And he's kicking a pebble off the river, like that. And so that's 18. So that's 0, 18 is our first coordinate. When the pebble horizontal distance is 12 feet, it's 26 feet in the air. Whoa. So at about here, at about 12 feet, it's 12 feet, it's 26 feet in the air. So that's our other coordinate, is a 12. And then, last but not least, when the pebble is 32 feet from the hiker, it's 8 feet above the river. So right about there, at 32, so at 32, it's 8 feet above the river. So we can do quadratic again and plug it into our calculator to answer some questions. So we'll get the equation, and we'll also plug it in and answer some questions. Here we go. So we go here, we go back to stats, back to edit our data. So we got 0, 18. And then what's our next one? 12. Enter, right arrow up, 26. Got to match. 12 goes with the 26. And then 32. And then 32 goes with the 8. So the x value, the horizontal distance was 32. The y value was 8 feet high. So those go together. Stat over to calc, quadratic. This time we're going to do something different. We're actually going to store that equation. And so you have to go vars, y vars, function, y1. Ready? Vars, y vars to the right, y vars. Function, push enter, y1, push enter. So that's going to store that equation we find into the calculator, and then we can graph it. Right? So now we go to enter. There's our equation. So let's write it down. Boom. So there it is. Our equation is y equals -0.0489. Well, that 9 rounds that 8 up to a 9. X squared, round to 3 decimal places, plus 1.254x plus 18. And so that's going to get plugged into our calculator where we can see this graph. Look how they plugged it in by doing vars, y vars, function y1. So then we graph it, and wow, it's way over there. So I'm going to push maybe zoom, and maybe zoom, I don't know, zoom standard, no, zoom fit maybe. Maybe that'll help us, maybe not, not really. So we're going to mess with the window a little bit, and we're going to say maybe -15. The y max, looks like it's going pretty far, like 50 or 40, I don't know, let's try 50. You're going to have to guess around until you find it. So then the minimum is going to be like, I don't know, -5. And it looked kind of like about 25, so that was okay, I think. Oh, nope, it's higher than that. Go back to window. So we got to go up to maybe like 30, for example. Yeah, now we can see the parabola and get the answer to the horizontal distance when it hits the water. And so that's this part right here. So what's that x value, basically? What's that x value? So you can go trace and go all the way down there. All the way down there. All the way down there. What's that x value? 30-something? So about 36, 35, 36. You can be exact. I don't know if I taught you this. So second calc, and it's called number 2. It's a 0 function. Enter. So we go left of that x-intercept, we push enter. We go right of that x-intercept, we push enter. And then guess right about there. So it tells us 35.8675. So 35 or not. What the? Oh no, is it frozen? Oh no, my screen's frozen. What's going on? Oh no, I can't cope. Let's see. Are we still recording? Are we? Oh, my whole computer froze. It's too much. Whoa. Whole computer froze. What's going on? Task manager. OBS. Is it freezing? Maybe it's the smartboard. Should I? There we go. Oh, we're still going. Yay, we're still going. Okay, so we get 35.8675 is our x-intercept. So 35.8675. So that 5 is going to round it up to an 868. So 35.868. Wayo. Okay, so what's the maximum height? So to find the maximum height, we're going to hit trace and go all the way up here to the top. Oh, too far. Okay, so that's pretty far up there, right? So do you know how to do the maximum feature now? So we go second calc, maximum option 4. So we have a left bound, push enter. We have a right bound, push enter. And then right about here, push enter. You should put all these steps in your note card. So we have a maximum of 12.8 and a maximum height of 26.032. So 26.032 is the very top of our mountain. So it's, where was it at? It was like at 12.8. So a little bit further, that's the top of our mountain. So that's 12.808 or 809. And then specifically our 26.032 is the y value. That's our maximum. All right, thanks for watching. See you on the next page, next video. Thanks for watching. See you on the next page. Thanks for watching. See you soon. If my computer doesn't crash on me.